Okay, so let's pick up where we left off yesterday. We were exploring the acceleration and deceleration occurring from the positive side of the number line to the negative side of the number line. We know that it takes 851,000 steps approximately through the gradient to do one revolution on the positive side. And I now know that it takes approximately 211,000 steps on the negative side to do one revolution, to do the first revolution on the negative side. But I've also found some other interesting properties. So if we right now C is set to 0, and this is our starting point. So this is a consequence of the fine structure constant and the golden angle. So this angle right here, the golden angle, subtract the fine structure constant essentially. The difference between those two angles is what's being plotted here. Okay. Now, obviously, the angle is not the same, but this calculation as a whole is kind of bizarre, anyways, and it's just this is just how it works out. I'm still trying to understand it completely. But we're going to use that as a starting point, and note that when I set C to 114,796 on the negative side, let's make sure we get the negative in there, that we are at exactly pi for this angle. Well, a very close approximation to pi. And then interestingly enough, if we go to negative 201,728, we're at exactly 2 pi, which happens to be the circumference of the circle, which is interesting. To get the full revolution, we're looking at basically about 211,000 negatives on the negative side, right? It's actually a little bit more, maybe 212. I have to check, but you get the gist of it, right? So basically, we have on the positive side, it takes 851,000 steps to the gradient to do one revolution. On the negative side, it takes about 211,000 steps to do one revolution, and that's approximately 4 times faster than the revolution on the positive side. And again, this acceleration gets faster as you proceed through the negative numbers. So what I'm going to do, just so that we can get a better view of this, is I'm going to set this to 0 again. I'm going to go into the settings for it, set the maximum to 0, and set the minimum to 500 million. Or actually, I'll keep it lower for now so that we can see. And let's just actually go 851,000, just so we can see the difference between the same values that we're using on the positive side. That's a good test. Okay, so I'm going to play this, and we'll just watch the acceleration and deceleration as we proceed through the negative numbers. Starting to get faster, starting to get faster. It gets to a point where you can't even keep count. And then it'll slow right down. Now, if we want to see it slow right down, let's just take this out to, let's say 10 million. Right? So you can see we're at negative 3 million, negative 4 million, negative 5 million, and it slows right down. And again, I did one test where I'm not completely confident on the result yet, but it looks like you get on the positive side, I've been able to get 2 full revolutions, and on the negative side, it looks like it's about 2,094 revolutions. But that's just approximate, and I have to do some confirmations on that, which is interesting. And I'm also going to break down that acceleration and how that maps out in the negative series of numbers. It's just really, really interesting. And again, this oscillation is artificial. The back and forth aspect of it, that's just a consequence of playing through the numbers. But the acceleration and deceleration from the positive side to the negative side is really what we're looking to get at the heart of here. It's just really, really interesting. It's also interesting how the first revolution on the negative side works out this angle to pi and 2 pi. So I'm going to leave that for now, and as I find out more, I'll definitely keep posting. Thanks.